Winter 2018. It's cold out here in the distant reaches of the solar system, close to 4 billion miles from Earth. And NASA's New Horizons robotic spacecraft is alone. But it's intimately connected to a team of human scientists and engineers back on Earth. It's their passion, skill, and commitment that powers the mission, just as much as its plutonium fuel. Using approach imagery, they're making final TCMs, trajectory correction maneuvers, to take it as close as 2,200 miles to its next target. After a journey of almost 13 years, New Horizons is closing in for a January 1st, 2019 flyby of a tiny world. It's officially known as 2014 MU-69. Now, this icy Kuiper Belt object is being informally called Ultima Thule, honoring the mythical land beyond the edges of the known world. And Ultima is the most distant and most ancient object ever encountered by any space mission. Those long years in flight have seen the awesome success of the 2015 encounter with the Pluto system.
We knew it was going to be scientifically rewarding. We had no idea it was going to be so beautiful.
But just 10 days before closest approach, New Horizons had its own Apollo 13 moment, when the mission ops team had to diagnose and correct a computer malfunction under the most extreme time pressures.
My heart did another flip. I thought, oh my gosh, I really hope it's not that.
That was almost a worst-case scenario.
Exploring the outer solar system is an endeavor in which the United States has led the world. But targeting the close flyby of Ultima has relied on support from nations and space agencies across the globe. It's taken the Hubble Space Telescope and the European Space Agency's Gaia satellite, powerful telescopes in Hawaii and Chile, volunteers and local governments in South Africa, Senegal, and Argentina, and an ambitious night flight aboard NASA's SOFIA Flying Observatory, deploying out of New Zealand.
The spacecraft has the capability of continuing working for several decades. January 1st of 2019 is just the beginning of another era of discovery for New Horizons.
Out here, in the eternal deep freeze at the edge of the solar system, are clues to how Earth and all the planets began and evolved.
This is even more challenging with Ultima Thule because it's another billion miles further out. It's considerably smaller. It's a very, very faint object.
Climbing Earth's tallest peaks requires the ultimate in passion and perseverance, technical skills, and the age-old longing to explore and achieve. Now, approaching Ultima Thule, this is the human story behind one of NASA's most ambitious missions, summiting the solar system.
Some people might think that there's not much happening after Pluto. We flew by, we got all the data down, but we are in the midst of planning. We're planning for our next encounter.
New Horizons is flying on past Pluto another billion miles to make a flyby on January 1st, 2019 of a small Kuiper Belt object.
For now, this KBO's official name remains 486958 2014 MU-69, or MU-69 for short. But in March 2018, it got its more evocative informal nickname, Ultima Thule, or Ultima, thanks to a public naming contest.
MU-69 is going to be a really interesting object because it is representative of the building blocks from which planets were formed.
2014 MU-69 is by far the most primitive and pristine object that we've ever had the opportunity to fly by. By virtue of its small size and its isolation, we believe that it is probably the closest we've ever been to something like a primordial building block of the planets.
So we've got the arrested development of the solar system waiting there for us to explore.
One of the most challenging aspects of the flyby is simply targeting the flyby. Never before has a spacecraft launched to a target that's not even discovered at the time of launch, much less tried to home in on something where we'll only have known about it for a small number of years and only tracked it through about 1% of its orbit around the sun. And yet we have to intercept it potentially even closer than we did with Pluto.
New Horizons sped by Pluto just 7,800 miles above its surface. But if all goes well, the spacecraft will skim only 2,200 miles over Ultima.
We are planning the sequences, what science we're going to do, or even planning ground-based observations to figure out where the target is.
Success will be powered by rocket science, but also by efforts much more down to Earth.
Just completed a huge occultation campaign in Senegal and Colombia on August 4th, 2018.
It was a huge effort. We sent 21 telescopes to Senegal. So we had 21 different teams, each with 2 observers from the United States, an observer from Senegal, someone who is knowledgeable in astronomy, a driver, and a military escort. So that's a lot of people scouring the countryside of Senegal to get in the shadow path.
If I'm the star, and this is MU-69 moving in past you, and you're the Earth, and observers are on the Earth, as MU-69 is moving in front of me, the star, it's blocking the starlight. And so if you were looking at the star, you would see it dim out over time and then come back up as MU-69 passes in front. You are effectively in the shadow of the starlight.
Kathy makes it sound simple, but the star which Ultima Thule will pass in front of is close to the center of our Milky Way galaxy, one of the starriest places in the sky. To help in understanding the incredible 4-dimensional problems the astronomers faced, with time a consideration as well as the 3 dimensions of space, it helps to think of a phenomena that's more familiar to many of us. The total eclipse of the sun that crossed North America on August 21st, 2017. Then, the star which creates the shadow is our local star, the sun. The occulting object is the moon. You had to be in the right place at the right time with the right weather and clear skies in order to catch the shadow. But if you were in the right place at the right time, you were treated to one of nature's most spectacular sights. For the men and women of New Horizons, things were a lot more complicated. In a solar eclipse, the relative closeness of the sun and moon to Earth means there's a wide area seeing a partial eclipse, and just a small region that witnesses totality. For the MU-69 occultation, the distances are much greater. The star emitting the light is some 25,000 light-years from Earth, and MU-69 is 4 billion miles away. That means the starlight is effectively a point source and casts a shadow on Earth that's only as wide as MU-69, about 19 miles across. And it passes over any one location in less than 2 seconds. Identifying which star Ultima will pass in front of takes 2 of Earth's most powerful astronomical assets, the Hubble Space Telescope and the European Space Agency's Gaia satellite, with both pushed to the very edge of their capabilities. It was Hubble that a team of New Horizons researchers used to discover tiny Ultima in 2014. Extrapolating its orbit from several repeat observations, they then used specially approved early access to the incredibly detailed Gaia dataset of more than 1 billion stars to figure out exactly which star MU-69 would pass in front of. It's a dim 13.4 magnitude star, and even finding the star that's going to be occulted in the night sky is hard. The observers used constellation patterns to target their telescopes at that dim star, somewhere between the teapot, with its bright star Nunki, and the teaspoon, Above Nunki, they used another pattern they nicknamed Evil Rudolph, with one bright star as Rudolph's nose, two eyes, and the antlers pointing to the actual target star close by. Another challenge. Unlike the position of Earth's moon during a solar eclipse, MU-69's orbit around the Sun is still relatively uncertain, since the object was only discovered, by Mark Buoy in fact, in 2014. That's not very long to track its speed and position. Although Ultima's exact size and shape is still uncertain, the best estimates are about 30 kilometers across, between 18 and 19 miles. For the August 4th eclipse, the shadow path would only be over land and accessible in West Africa and the top of South America. The green line is the predicted center of the shadow path. The dark blue lines show the edges of MU-69's shadow, and the yellow lines show the limits of telescope coverage, allowing for uncertainty. The team in Senegal, also led by Mark Buoy, had 21 telescopes. To maximize their chances of capturing the shadow, the observing teams would be placed 4 kilometers apart, along those light purple lines, in what they called a picket fence pattern. Given the uncertainties of clouds and rain, the team researched more sites than they had telescopes in order to be able to change deployment locations depending on the weather. And of course, they'd be looking for a less than 2-second shadow in the dark of night. Weather wasn't predicted to be completely favorable in either Colombia or Senegal, which was why Mark was hedging his bets by deploying telescopes on both continents.
Just about any other time of year, Senegal would be a lovely place to go do an occultation. But as luck would have it, we were there kind of at the middle of the rainy season for Senegal.
The anticipation was that this was going to be a problem, and it was.
In late July, the Americans arrive in Dakar and check into a newly built airport hotel for the first couple of days. They met their Senegalese colleagues and astronomers from France and practiced their observing protocols.
And we got a couple of practice nights in. We got to set up the equipment, make sure it made the journey all the way from Boulder, Colorado to Dakar, Senegal safely. We set up the systems and tried them out. Everybody got to practice with them.
So our Senegalese teammates were definitely enthusiastic about helping us and participating in this event. I think they all really appreciated that this was an incredible opportunity to take part in mission-critical observations for NASA. I mean, NASA has a worldwide brand. Everybody recognizes it, so it wasn't hard to make those connections.
I was very intentional in setting up these expeditions this year to involve the locals as much as possible. In Colombia, we were tied into the amateur astronomy networks, and everybody that they knew there to get help. In Senegal, I reached out and said, look, I want your people as equal partners on these teams.
The Senegalese colleagues that we worked with, they were outstanding. They all had a really strong interest in science and engineering, and they were dedicated to helping us get the data.
From the very first day that we contacted the Senegalese, through the embassy, our project crossed the desk of the president of Senegal. He knew about it. He saw it and in an instant said, I want our country to be involved in this. And he put his best people on it.
Mark had been up late, advising the observing teams and speaking to TV journalists.
I got up at like 2 in the afternoon from being up the previous night. I'm trying to get everything organized, everybody ready, and all sorts of crazy stuff. And Adriano Campo from NASA headquarters comes in and says, the president wants to meet with us. And then a half an hour after that, we're all on buses going down to the presidential palace.
Suddenly there was a message on Slack that said, oh, hey, we need to go meet the president. Put on your best clothes.
So we are about to go meet the president of Senegal.
And the palace grounds were absolutely beautiful.
Thankfully, I had some decent-looking shoes. There are a lot of people who just had, like, sneakers.
Of all the expeditions I've done, this is the first time I have ever had to meet with a head of state as a result of an occultation. The atmosphere there was just really amazing. And all of the people that were involved, all being on board with this kind of effort and doing what it takes to make it a success.
After the ceremonies, it was time to head north to the observing sites. But the high-level attention and support continued.
We definitely had a full convoy led by police escort leading us the whole way. If there was any traffic that looked like it had potential to hold this group up, they were told, nope, you let this group through. So we made very good time.
So we just arrived in Luga. We're going to go out and practice tonight, and then tomorrow night will be the occultation. So more than half of our group has come to Luga so that we can be spread along the occultation path.
In Luga, the planning intensified, with Mark running through which team would go where, and the Senegalese partners detailing logistical support, ranging from adequate drinking water to protection against snake bites.
In Senegal, we had 21 stations deployed out in a picket fence, roughly over about 150 miles or something in northern Senegal.
We wanted a very tight picket fence. Each system was a cut across the shadow of Ultima Thule as cast by the star.
At last, they set off for occultation night, August the 4th, Universal Time, hoping for clear skies. But after all the preparations, not even presidents or NASA can control the weather. Most teams returned to Mark, who was anxiously waiting at the hotel, without having seen the occultation star blink out because of clouds or even rain.
I knew as people were filtering in, I knew what my result was. We got clouded out.
I'm sitting there and team after team is coming in saying, clouds, rain, no.
All the people with me were so disappointed, and I felt really bad for them.
We'd spent so many months working so hard for this one moment, and it's not looking really great.
Aaron Resnick had spent much of the first few days on the phone, trying to reach someone back in the States to help fix broken equipment. Like everyone on the team, he'd had to juggle travel, logistics, and keeping hydrated, but he also made time to engage some new friends. Peter Tamlin from Sweary was Aaron's observing partner.
Aaron Resnick and Peter Tamlin come in and said, hand me that stick and said, you've got to look at this. That was amazing. And he says, we got it, we got it. They were absolutely sure that they had seen it and the star had disappeared.
Took a quick look at the right time and, oh yes.
We were all looking for Amanda to be analyzing the data, and then she said, yeah, I've got it. And we rushed over to her computer screen, and everybody was crowded around looking at it, and you could see high points where the star wasn't occulted by MU69, and then it would drop down and you couldn't see the star, and it went a few points and then it came back up. So it was just a really clear signal that we got an occultation.
Out of the 21 stations that we sent to Senegal, 2 got data that were unaffected by clouds for the minute around the time of the occultation.
That is going to help us be able to navigate the spacecraft successfully to Ultima Thule, because that gives us another point to add to our arsenal of where Ultima is.
It was absolutely the best possible result that we could get out. It gives us a lot more confidence that we're on the right track with the spacecraft trajectory as we know it right now.
So, in the final months of 2018, New Horizons was perfectly on course for its next target. Expectations were building, just like they'd been in 2015, as the spacecraft closed in on Pluto. Before New Horizons arrived at Pluto, NASA's last first-time visit to a planet had been 26 years earlier, in 1989, when Voyager 2 arrived at Neptune. Many future members of the Pluto mission had been at JPL, watching the images of Neptune and its moon Triton scrolling up line by line. John Spencer had longer hair then, but already always had a camera at hand. With no new missions to the outer planets underway, many wondered what would be next. 2 years later, the U.S. Postal Service issued a set of stamps commemorating America's visits to the innermost 8 planets and honoring the spacecraft that had reached them. But the stamp for Pluto read, "Not yet explored." That rankled planetary astronomers at JPL and added to the ambition of Alan Stern, Mark Buoy, Fran Bagenal, and others who, in 1989, had already dubbed themselves the Pluto Underground and started pushing for a first mission to the last planet. Finally, in early 2015, a spacecraft began approaching Pluto.
In the months and weeks leading up to the Pluto encounter, every day was exciting. Every day brought new information about Pluto and Charon and the small moons. We would have new views of Pluto, unlike something that we had ever seen before. I felt like I was a kid in a candy shop. I would go to work, 7 days a week, be there all hours of the day because there was nowhere else that I wanted to be. That was where the excitement was happening. That was where the new data was coming down. We were seeing something new that we had been waiting more than a decade for. And it was really exciting every single day.
The approach to Pluto in anticipation of the flyby was an amazing period of time. I've been working on Pluto for decades, basically spent my whole life and career working on studying this distant world. And to finally be able to open the box and find out, one, was I right in all of the research that I've been doing, and what else is going on there that our imaginations fail us in figuring out what's going on Pluto.
It was very hectic. Every day we would get a little bit more data on Pluto up until the encounter.
I was kind of expecting maybe, a dead world, and what we got was anything but. And every time something else came down, it was just another triumphant moment.
After waiting so long, we were so keen to see what it would look like. And it was kind of funny, each team meeting, they'd show a picture of Pluto. This is the latest. And it was, to be honest with you, a fuzzy blob. And then a slightly larger fuzzy blob. And then a little bit bigger fuzzy blob. And indeed, it really didn't look like much until we really got there and we really got to see the pictures.
All was going well, but with the forethought that characterized the entire mission, they'd planned what they called a fail-safe image, a final full-frame picture from the long-range camera LORRI to be sent back before the closest approach, just in case something went catastrophically wrong. In the months leading up to the encounter, they'd carefully searched for hazards near Pluto, a ring or a small moon, or even grains of dust that could collide with the spacecraft and end the mission. They thought their close approach trajectory was clear, but there was always that unknown unknown. Alan Stern, with an eye towards a dramatic reveal, charged a small group with taking that fail-safe image and working on it in secrecy overnight to be ready for an early morning science meeting, after which it could be shared with the whole world. One of that team was Alex Parker.
There are moments that will, live forever in my memory as recognizing that I'm part of something that is only going to be witnessed one time. This first revelation of Pluto.
The group of us got together: John, Alex, Todd Lauer, Carly Howlett, myself.
My primary work is on the color imager of New Horizons, and so there was a lot of work going into the calibration so that when we got the images back, we could quickly process them and release them to the public and to the scientists so that we could get the most out of them.
So it was myself and a few other members of the team that were given access to the first best look at Pluto that night before encounter, that last fail-safe image that we took on approach. And we're tasked with combining it with our earlier color image to reveal to the world at 7 a.m. the next day.
And so the five of us were there, and then Hal Weaver was sticking around to download the image. He wasn't originally even going to see it, but he sort of downloaded an image, and he brought it to us on a flash drive, and we put it in, and we looked at it, and like, wait, what the hell is that?
The spacecraft had sent back the correct image. Simple operator error down here on Earth called up the wrong picture.
And it turned out to be an image of Sharon that we had linked the day before. It looked nothing like Pluto. If that was what Pluto would look like, we would have been very disappointed. But then we went back and actually found the correct image. And so we first saw it on Hal's monitor in his office.
It was incredibly exciting, and I'm British, so we don't sort of use words like incredibly very easily, so it was incredibly exciting. It wasn't like the Voyager days when you have a line at a time. All of a sudden this image just comes up on your screen.
I remember just walking back from Hal's office, my arm was just shaking like this, because I've just been waiting so long for this picture, and we finally saw it.
The fail-safe image was so many things. Yes, it was brown, and you get something from the color, and it was also had so much going on in the image itself. You were trying to, like I said, you're trying to sort of decipher all of those things simultaneously, and I think everyone was, and sort of doing geology on the fly and doing chemistry on the fly, and just coming up with wild ideas. What do you think this could be? What do you think this could be? And sometimes you get caught up just sort of staring at the images and then realize, oh no, quick, we're supposed to be working on something else.
For that evening, the five of us were the only people that had ever seen Pluto up close. And so there was that period in time in which myself and these others were privy to this knowledge of what that last world looked like.
Not only was it one of the best images we've ever had of Pluto in terms of spatial resolution, but it also was a very personal thing for me. It felt like you were on the cutting edge of discovery.
I certainly felt shocked when we first saw that image.
Around 5 a.m. on July 14th, the mission team left their hotel for APL. After 26 years of effort, Alan greeted his colleagues as their long day began.
Well, how about a Pluto flyby, everybody? So last night, the spacecraft went over the hill. We'll be hearing from it about 9 p.m. Eastern time tonight. In the last transmission from the spacecraft, everything was good on board, and we got down our last image, which is, of course, the Pluto Lori full-frame image. There's a small team of people that worked very hard overnight till 3 a.m., and I'd like them to stand up for some thanks.
At this time, the newly processed high-res image was still embargoed, waiting for Alex to release it to Hal and the world.
And then we got to be there when it was revealed to the rest of the team and the rest of the world and see how they responded. And that was really a spectacular feeling. Alex hit send, and the image sped to Hal. Carly was super pleased.
History is...
But as often happens, computers don't work quite as fast as you want them to. After 26 years, the team was getting understandably impatient.
Oh, I set the exposure time wrong.
And I think it's the iconic image that came out of the encounter. The reason that I think it's so wonderful is, A, it's got amazing spatial resolution. You can tell so much about Pluto just by looking at that image. You can tell things about the geology and the topography and the activity and so many things that we didn't know about Pluto existed until we had that image. It's been a single pixel really for a long time, and so you sort of had that feeling of disbelief.
So this is my chance to say a little something. 22 years ago this summer, a few of us were at a conference in Flagstaff to put together the case to go to the Pluto system. Many of us made predictions. And with this image, I've been proven right because my prediction was what we would find was something wonderful. How about that?
We knew Pluto would be good, but I don't think any of us expected it would be this good in terms of the scientific riches.
Sometimes good things come in small packages, and I think that the dwarf planets have been vindicated this morning.
They were thrilled by the high-res black and white, but then it was time for the color image that Carly, Alex, and their small group had worked on so hard overnight.
It was an exciting thing to see this black and white world move into a color space.
So we knew it was going to be scientifically rewarding. We had no idea it was going to be so beautiful.
I saw a new side of people because it was just such a new experience for all of us. Just the sheer joy of being able to be present for the newest and the latest and to make these groundbreaking discoveries.
That's my favorite part, right there. I did color-wise.
When that first picture came back and showed that gigantic heart on Pluto, oh my gosh, I can't explain the feelings that you got.
I think my favorite picture from the encounter is the one that shows the full view. I think that really stands out. When I think of a picture of Pluto, I think of a sphere with a heart.
We saw this spectacular view of the surface of Pluto with all the mountains, the plains, the high elevations, the different colors.
You know, you have people that have spent decades trying to understand the solar system and its evolution, and they know more than anybody else on the planet, and yet they're sitting there saying, wow, what is that? I mean, that's just really special.
I think I was surprised most as a scientist by how complex Pluto looks. And I remember thinking that even when the very first images came back, and how varied the terrains are.
You thought, after all these years of such hard work, this is all worth it, even if we only got that one image.
It was like a wow moment. Everybody just went berserk.
I was utterly amazed with the complexity of the surface. We had no idea that it was going to be as exciting as it was.
Will Grundy started sharing details of Pluto's surface composition, and the team began to realize the incredible richness of the data that New Horizons had captured.
This is false color. What you see here is that there is just an incredible range of compositional diversity.
Well, when those first images came back, I remember thinking just how proud I was that we had pulled this off and that it had all worked, and that people's over a decade, 15 years of nights and weekends and everything else it took had gone so smoothly. And more than anything else, that's what I think I was thinking about on the morning of the flyby. Just pride in the 2,500 Americans that had worked to bring this from an idea on a sheet of paper to a spectacular scientific success.
One of my favorite pictures from that first day is a picture of a dozen geologists up against the big display of Pluto, pointing out all these things. Oh, is that this? Is that this? Doing instant science in that first half hour.
While the science room was abuzz, the Mission Operations Center was empty, except for a cleaner. New Horizons was alone in space, running through the pre-programmed commands that had been radioed up a week ago. The spacecraft was busy with some 236 separate scientific observations. All 7 of its instruments were focused on Pluto and its 5 moons. There was no time to turn the antenna back to Earth. Although New Horizons was alone in space, it was, of course, very much on people's minds at APL and those watching NASA TV coverage around the world. Alan led a countdown to the actual moment of closest approach.
6, 5, 4, 3, 2, 1, New Horizons and Pluto 2015.
Then it was time to cancel that stamp from so many years before.
A long time ago, the United States issued a set of stamps for the exploration of the planets, honoring all of the spacecraft that have been first to each and every planet. And we have a copy here of the stamp that was issued for Pluto because it was the only planet that was not yet explored. This is from 1991. You can buy these stamps, but about 2 minutes ago, we just made it obsolete.
But for all the excitement of the failsafe image and that moment of closest approach, the real proof that New Horizons had gathered the goods at Pluto would come that evening. That was when the spacecraft had been programmed to phone home, reporting its status. This was the scene in Mission Control, waiting for Mom, Mission Operations Manager Alice Bowman, to confirm the receipt of a signal, verifying that all had gone well.
We are searching for frequency. Stand by.
Had New Horizons run into undetected debris and dust? Had it survived closest approach?
Just go ahead, autonomy.
Autonomy is very happy to report nominal status. No rules have fired.
Okay. Go ahead, GNC.
GNC is nominal, all hardware is healthy, and we have a good number of thruster counts.
Copy that. GNC is healthy. Okay. PI, Mom on Pluto 1. We have a healthy spacecraft. We've recorded data of the Pluto system, and we're outbound for Pluto.
With a healthy spacecraft and the expectation of a bonanza of new science, the entire New Horizons team, including NASA's VIPs, headed over to APL's largest auditorium for a broadcast press conference.
Ladies and gentlemen, please welcome New Horizons and the team.
On this occasion, the men and women of Mission Ops were feted as rock stars. Engineers being recognized as equally important to the mission as the scientists. NASA's then Administrator Charlie Bolden, a former astronaut, made congratulatory remarks, and the engineers went back to work. Astronaut and Associate Administrator John Grunsfeld shared a tweet from President Obama. Glenn was feeling good. Alan answered questions. Alice took a bow. America had finally completed the reconnaissance of the classical solar system. 50 years to the day after Mariner reached Mars, New Horizons had a successful encounter with Pluto. July 14th was finally over, but a new phase of the mission was just beginning.
For us, July 14th was when all the action happened and it was a time to celebrate. But then July 15th was when the real excitement began because we actually started getting to see what New Horizons observed.
I would say every day we got a new surprise, but every day we got 10 new surprises.
You would have a whole bunch of people gathered around a given computer screen. And you knew something was going on, so of course you glommed onto that and looked, what is this? What's the new data?
And everyone would just stay late, would get in early. We wanted to come in, we wanted to see what new images, what new discoveries had been made overnight or earlier that morning.
All the pictures were different and they were all spectacular.
Pluto is a collection of the world's coolest national parks all put onto one planet.
Weird ices and flows. Yes, there were impact craters, but they had this rim of frost around them. And then we had cracks, and then we had this brown, oily, gunky stuff on the surface.
There's this large glacier on Pluto, and there's a huge canyon on Charon, and that the North Pole of Charon is red. And what does that mean?
All of it told these stories that were either not necessarily what we expected or so far beyond what we expected that, no one would have seen it coming.
Some people are lucky that they discover one thing in their entire career, and that's an amazing thing. I felt like we were discovering one thing a minute.
The moment when one of my colleagues walked into the room carrying his laptop and saying, "There's haze," and flipping it around and seeing that first departure image that we got where we could see the loop of light around the outside. And this was something that none of us really expected. And so I was then the one that walked into the atmospheres room with a laptop to show them the image, and to see them just hit the ceilings with joy and excitement, and worry a little bit about their heart health. That was quite a moment.
The pace of science I've never seen before or since.
We're all human, and we all wanted to see what was the newest and the latest, and that excitement was just really evident in every room.
Being in the room when we got the first color image down that showed that the two halves of the heart were different colors, and that was our first clue that they were two very different kinds of terrains, just moment after moment like that.
It was a magical time, and those memories will last a lifetime for me.
Nothing I'd done prepared me for this type of discovery. It's science, but it's also discovery. You don't get that sense when you go through schooling. It's a very unusual thing to be a part of, in the sense of that much discovery in that short a time frame.
From day one, it was clear that Pluto had exceeded expectations. Though small, it had active geology. Some features looked Earth-like. Others were strange and completely unfamiliar. Every day, during the 16 months it took flyby data to return, the science teams were hard at work, adding new chapters to the annals of space exploration, and starting to write up tales of two planets. Once the science team had time to study the amazing images that were returned on July 14th and in the months to come, they were astonished to see that Pluto showed many examples of phenomena also seen on Earth. Glaciers, volcanoes, mountains, and even blue skies. Soon they were engaged in looking at what seems similar and, many times, completely different.
Planetary scientists love to compare similar processes on different bodies. It's called comparative planetology. You compare the different experiments that nature has done.
We're all wired for comparative planetology. We can all look at one thing and it'll remind us of something that we've seen before.
We use what we know about the Earth to try to inform our knowledge and understanding of what's going on Pluto.
We see these analogs, but in completely different contexts on the Earth, and yet they behave the same way, but at vastly different conditions, and for materials that are vastly different from each other.
On Earth, we have glaciers that are made out of water ice. On Pluto, we have nitrogen ice glaciers. How do they differ? How are they similar?
The single biggest feature on Pluto's surface is a region that we call Sputnik Planitia, which is this giant sheet of nitrogen ice, frozen nitrogen ice.
This vast plain, smooth plain, had no craters whatsoever. It was gigantic. It's the size of Texas and Oklahoma combined.
It almost fills one hemisphere of Pluto and produces the left ventricle of that heart of Pluto.
We had no idea what we were looking at first. It took us a while to even develop some hypotheses of what this could possibly be.
And Sputnik Planitia, I like to say, gives Pluto its mojo. It really is the source of almost everything that we see on Pluto. This giant sheet actually moves like a glacier.
That, to me, is such a favorite because it's like, wow, that place is like, it's like here. You know, you see things that we see here on the Earth with materials that are completely different.
It's very much like a water ice glacier on the Earth. It flows, can flow around barriers.
The secret to Pluto's activity is that its surface is full of these very mobile, super cold ices, solid nitrogen, solid methane, solid carbon monoxide, and it doesn't take a lot of energy to make this stuff move.
The bonds that make nitrogen ice crystals are different than in water, so they're actually weaker.
Nitrogen ice is very soft. It has kind of the mechanical properties of a slightly stiffer version of silly putty.
But when you look in detail, you see that there are these giant sort of blisters that are separated by little sort of ridges. And these blisters are maybe 30, 50 kilometers across. They have the pattern of upwelling and downwelling material that's moving slowly like
churning oatmeal on a stove.
The surface has all of these polygons on the top, and we think that they're convection cells. So what this is saying to us is that there's a heat difference between the top of that nitrogen ice and the bottom of the nitrogen ice.
The core and the mantle of Pluto have just enough radioactive material in it that slow decay of the radioactive material produces just enough heat to stir these extremely volatile ices, which are mobilized at only a few tens of degrees above absolute zero.
It's sort of like a lava lamp. You get the heating of the material in the lava lamp, these blobs go up, and when they cool, they come back down, and that's similar to what's happening to this nitrogen ice on Pluto. And what that means is that surface is relatively young, geologically speaking. And in fact, we had our highest resolution images cutting across Sputnik Planitia, so if there were craters there, we were going to see them, but we didn't detect any.
But to the south of Sputnik Planitia, there were two round shapes. These were too large to be craters. Even now, there's some uncertainty about exactly what they are. But once again, knowledge of what makes such shapes on Earth made many on the science team suspect they were seeing volcanoes. Although volcanoes operating very differently from here on Earth.
Pluto revealed a lot of surprises. Those huge craggy peaks all around the edge of Sputnik Planitia were mind-blowing enough. But then to see another construct, another mountain in the southern end of Sputnik Planitia called Right Mons is even more mind-blowing because it doesn't have the same shape as those, and we need to have some other way to explain that object. This construct looks like unlike anything else on the surface of Pluto, and immediately got all the geologists thinking, I wonder if this is a volcano.
They're giant mounds, 100 miles across and a few miles high. These potential volcanoes on Pluto have some similarities to a shield volcano on Earth, like you might see in Hawaii. They're very big, broad mounds, but there's one major difference, and that is that they have huge central depressions, whereas the shield volcanoes on Earth have a tiny little caldera at the top relative to the size of the feature.
In 2018, Kilauea on the Big Island of Hawaii began a series of eruptions and lava flows that changed the landscape and made the observation deck close to the summit too dangerous for both tourists and scientists. We were one of the last film crews to work there.
We're here on the summit of Kilauea on the Big Island of Hawaii. We're looking at a volcano on the Earth, which we know of as hot lava flowing up out of the ground. And that's what's making the red glow that you see, which is volcanism in action on the Earth. Volcanism is a process that happens on many solar system bodies. What you're talking about is a liquid that is at depth and it gets erupted onto the surface, cools, and freezes. So on the Earth, we're talking about rocks. Stuff that we're standing on here, as it's erupted, is incredibly hot and molten, flows out onto the surface, and then it takes on these shapes and forms that we see around us.
Some of the lumpy textures that we see on the flanks of the icy volcano are similar to the shapes of the Pahoehoe lava in Hawaii, except that they're much, much bigger.
Right Mons on Pluto is about 90 miles across and over 2 miles high. And that compares with Mauna Loa, about 70 miles across and again about 2 miles high.
These potential volcanoes on Pluto, we think that instead of an explosive type of eruption like we might have on Earth, we have more of an oozing of material coming out, building up the mound over time. And this material is icy, but it can still flow. So if you imagine something like toothpaste flowing or ketchup flowing, it's solid, but it can still flow.
So here we are on the flanks of Kilauea. You see lava all around here. It's maybe 20 years old. The important lesson here is about time. When you get up close and look at this stuff, you can see here's this darker material, smoother material. It's all different. You can see one on top of the other. And this tells you that this construct formed over time. This is one of those central mysteries that we've got to understand about Pluto. There aren't any craters on right Mons, and that tells you immediately that something's happened. Something has resurfaced that area of Pluto, just like this lava here has resurfaced the Earth and erased a road. In the case of Pluto, we would be erasing craters and show that it's a very young feature. Did Mons form in just one impulsive event in a very short period of time, or did it take millions of years to form? All we know right now is that it's very, very young.
And while the volcanoes remain mysterious, the spectacular mountain chains that dot the planet were more easily explained. What was perhaps most amazing was that these peaks were made not of rock, but frozen water ice, H2O.
The mountains of the Earth and Pluto can be compared. In many ways, they're similar, but in many ways, they're also different. One of the great differences is that on Pluto, those structures exist in a much lower gravity environment. Much more fragile structures can ascend to great heights, for example.
At the surface temperature of Pluto, ice is as hard as rock. So that's your bedrock, so to speak, is bed ice.
The nitrogen ice actually can buoy up giant blocks of water ice, forming mountains as high as the Rocky Mountains in the United States, sticking up like giant icebergs.
And sometimes they're snow-capped with other materials like nitrogen or methane, but they're constructionally made of water ice in enormous blocks that stretch 15,000 feet into the sky above Pluto's surface.
Mountains are really, really rare in the solar system. There are places that we call montes around the solar system, but for the most part, like on Mars, they're just lonely mountains out by themselves, big shield volcanoes. You don't get mountain ranges like we have on Earth because they're, have plate tectonics on these other planets. But you have something not quite plate tectonics, but that still moves chunks of material around like plate tectonics do on Pluto, and so you get these distinct mountain ranges on the margins of Sputnik.
Like Simon, many members of the New Horizons team work at the Southwest Research Institute in Boulder, Colorado, since that's where the mission's principal investigator, Alan Stern, is based.
A lot of the people in the room were from here, so I made the comment that, we sent a mission to Pluto, but it actually took pictures of Colorado because when we first saw the Norgay Montes, it just so happens that first really high-resolution picture we saw of Pluto was of mountains.
Now, I'm a rock climber, and I love climbing up rocks. And so instead of climbing rocks, we would have to climb ice, up these big mountains of ice. But ice covered in brown, oily, gooey, gunky, yucky stuff that's rained out of the sky. Very bizarre and extremely difficult to climb.
As New Horizons departed the Pluto system, it looked back to Earth as radio waves were beamed up from NASA's Deep Space Network's largest dishes to the spacecraft, revealing the depth and pressure of the planet's atmosphere. But along with the science, New Horizons captured images that were eerily familiar.
Who would have thought that Pluto's atmosphere would be blue?
Although the physical processes are different, both Earth and Pluto have blue skies and complex atmospheres containing nitrogen. And, just like Earth, Pluto's atmosphere is dynamic and variable.
Well, Pluto has weather the same way, really, Earth has weather, or Mars has weather, or Titan has weather.
So Pluto is just like Earth in that it has a bunch of different weather and climate cycles. On Earth, we have the day-night cycle, and it gets warm during the day and cools off at night. Everything happens a lot faster on Earth because we're just closer to the sun. There's more energy, we go around faster. So the gusts here today are approaching 70 miles an hour. Actually, it would be very windy on Pluto too, especially around Sputnik Planitia. In the daytime, the ice sublimates and the wind blows out of the crater, and at night, that air cools down and flows back into the crater very violently. That's called a katabatic wind. So right around the edge of Sputnik Planitia is probably some of the windiest places on Pluto. It's where you would want to look if you wanted to look for dunes, for instance.
One reason some aspects of Pluto seem familiar is that many members of the science team had been studying small-scale phenomena that prepared them to understand this brand-new planet. Will Grundy and his colleagues on the science team, like Dale Cruikshank at NASA Ames, have been running lab experiments on the exotic ices known to be present on Pluto. They've found that radiation changes colorless ices such as nitrogen, methane, and carbon monoxide into yellows, reds, browns, and black.
There was never a time when I didn't think Pluto was going to be exciting. And the reason I was pretty confident about that was because I've played with the materials that are on the surface of Pluto, nitrogen ice, methane ice, carbon monoxide ice, in the laboratory at about that scale. And I've seen all kinds of weird phenomena going on in the laboratory. So I know these materials do interesting things. But what I lacked was the imagination of saying, grow that little sample, a 1.5 centimeters across to the size of a planet. And what can it do? Holy moly, it can do a lot. And they can make just incredible landscapes. It's really the combinations of materials where the magic happens. But what we didn't, I think, really imagine was what just a wealth of landscapes it could make, and on such a grand scale.
As a person, what surprised me the most was how beautiful the landscapes are on Pluto, with twilight hazes and a blue sky and big ravines, gorgeous mountain ranges that have snow caps on them. And although there are craters on the surface, and you can certainly tell it's a faraway world, I don't think there's a more photogenic planet other than our own in the solar system.
But all this amazing new science would not have happened had not New Horizons engineers solved an anomaly that threatened the entire mission just 10 days before the triumphs of July 14th. Here's the human story of that anomaly and the recovery. We now know the New Horizons flyby of Pluto on July 14, 2015 was successful beyond even the wildest dreams of the men and women who've been longing for that day. What's little known is that just 10 days earlier, July 4, 2015, the mission came closer to disaster than ever before. How they recovered is a testament to everything that made New Horizons successful. Now, for the first time, let's go behind the scenes to hear how they did it.
July 4th, 2015 was one of those days that started off not quite what you would say normal.
About 3, 4 in the morning, I drove into work, so I was responsible for uploading the main flyby sequence to the spacecraft and sending the commands to store it into memory.
Principal investigator Alan Stern came in as well, wanting to be present for this major mission milestone.
And then when that was done, I went home and I had a 9-hour wait, so I took a nap and played with my kids.
The encounter load takes up 80% of the spacecraft memory. And because of that and the special operations we do to ensure that the commands are successful to capture this encounter data, it takes 2 hours to radiate this set of commands from Earth at 2,000 bits per second. So we started that upload at about 4:30 in the morning, Eastern Time. This was our first opportunity to put the encounter sequence set of commands up to the spacecraft.
8 hours later, Alice, Carl, and others dropped in for what they thought would be just a short visit.
I had to come into work that morning to check on the final load and flash burn to the spacecraft.
Well, our plans were for me to finish up my shift at 2 o'clock in the afternoon, and then I was going to come home, and my husband and children and my parents who live nearby were all going to walk over to the fireworks display.
So I was actually at the swimming pool at a barbecue.
We were going to watch 1776, the musical, and then maybe step outside and look at the fireworks.
I was at home. It was a Saturday. I had my laptop with me.
So I came in with the intention of spending about an hour to verify everything was good, and then clocking out, going home, and enjoying the day with the family and going to see some fireworks. You know, we had plans.
For the first hour or so, everything looked great. We saw those commands being received by the spacecraft main computer. And at 1:54 in the afternoon, We lost all comm with the spacecraft.
The software is designed when the number stops changing and we're not getting updates, it goes gray. So all the numbers were green or yellow or red, whichever color they happen to be, mostly green. Green is good. And then they all went gray, which meant that we had lost our signal, our telemetry signal.
So the original plans on July 4th was to spend time with the family, going to visit my sister in Baltimore. And on our way to driving to see my sister, I get a phone call from Carl. And I guess it's safe to say he probably wasn't calling me to wish me a happy 4th.
I get a phone call on my cell phone, and it's Alice. And she goes, Gabe, I don't want to worry you, because she knows how wound up I was that year. But she says, we lost contact with the spacecraft. We're not quite sure what's going on. Can you come in? And lo and behold, the worst thing that we possibly could have happened.
If you've ever been involved in spacecraft operations, that's the worst situation that you can be in because you have absolutely no information.
We contacted the DSN and verified that it wasn't a ground problem.
Sometimes in the past, storms over one of the deep space network dishes that link Earth and New Horizons, or ground station glitches, meant mission controllers at APL hadn't done anything wrong.
For me, it means that I didn't screw anything up, that it was the antenna's problem and not the spacecraft.
We also were checking our ground station to make sure nothing had gone out of spec there. And, it started to sink in that we were actually having a problem on board the spacecraft.
Now it was Alice's responsibility, as standard NASA practice for possible loss of mission, to declare a spacecraft emergency and begin investigating the anomaly.
Declaring an anomaly for the team, it just means all hands on deck, everyone come in.
So when I got to the Mission Operations Center, Steve Williams, who is the Command and Data Handling System lead, had been watching telemetry online from home, and he had noticed that the spacecraft had been compressing data at the same time as they were burning the command load to flash.
We've got all this data compression going on. At the same time, we're programming flash memory. We're not supposed to do this.
And this is something that he knew we shouldn't have been doing at the same time.
To understand what had gone wrong, you have to look inside New Horizons' brains. On board are two almost identical computers, providing redundancy over the long lifetime of the mission. These two integrated electronics modules both contain a brain known as the Command and Data Handling System, CNDH1 and CNDH2. Each CNDH can control the spacecraft's guidance and control systems, interface with the science instruments, talk to New Horizons' mouth and ears, the radio antennas that speak and listen to Earth, and to its all-important memory, a solid-state recorder. CNDH1, which was being used as the primary computer, was called the bus controller, or BC, and was supposed to be the main processor throughout the encounter, assuming the backup, known as the remote terminal, or RT, wasn't needed. CNDH1 was both receiving the complex and critical core load from Earth and, at the very same time, compressing the 63 Pluto images that had already been taken on approach by burning them to flash memory.
At that point, the proverbial light bulb went off in my head, and that was done during some stress testing that occurred before we even launched. The processor got very close to resetting. It probably reset this time. That's probably what happened. So I called Chris back, told him what I thought I knew or knew about this, and that's sort of when the procedure started.
In the Mission Operations Center, the MOC, Alice was also looking for clues.
I said to Brian, tell me what could be going on the spacecraft, given the situation, what we were doing and the situation that we're in now. And he said, okay, there's two things that I think could be going on. One of them we've seen before,
Normally, it's a processor reboot. That the CNDH-1 processor resets on board the spacecraft, and there's all sorts of reasons why that could happen. Radiation causing bits to flip in the memory, and if too many bits flip, we reset to restore the memory.
And one of them we've coded for in the software, but we've never seen in flight.
And the other possibility that we thought was potentially more likely was that we swapped from the main processor to the backup processor. We've never done that in flight, not even to test it out.
Because the command sequence is stored in the same memory blocks as the autonomy code, the flash burn has the potential to wipe out not only the command load, but also the software on board that keeps the spacecraft safe.
My heart did another flip. I thought, oh my gosh, I really hope it's not that.
There are several aspects to why it was so bad. We'd never run a simulation where we had that particular failure. And so I was like, okay, that's going to be the one that gets us.
I allowed myself that 10 seconds of absolute fear and that feeling in the pit of my stomach and said, okay, I've got to lead this team. This is my job.
Well, Pluto encounter was well and truly underway. And July 4th, of course, is a big holiday, and so time was of the essence.
That was the big thing, is the time pressure of it. Most of our anomalies that we've had in the past have been at times where we knew we had leisurely days to recover. In this case, we knew that we were loading the prime sequence. We were going into encounter mode in just a few days.
I'm thinking, we've flown this mission for 9.5 years. We've done all due diligence, we've simulated, we've tested, we've built I don't know how many versions of this encounter load. We've gone through contingency planning. We've looked at everything, and here we are experiencing this problem at this particular time.
That was almost a worst case scenario that we had thought about and hoped would never happen, and had never happened in the previous 9+ years on the way to Pluto.
If New Horizons was still intact and in its safe mode, it was pre-programmed to call back to Earth for new instructions. Exactly when that happened would be a key clue as to its condition.
So we asked the DSN to reconfigure for the processor swap so that if that's what happened, we would see our telemetry, and if that's not what happened, we would still have another, I think it was 45 minutes before the other configuration would have kicked in. So we had our best shot at most efficiently recovering the spacecraft.
Before that first bit of telemetry came back and you didn't know exactly what was going on, you were just sort of in this wait and see type mode.
We were all sort of on the edge of our seat waiting to see that telemetry.
It was eerily quiet.
The first signal came back exactly when we expected it to, which was a relief.
And everyone just kind of sat back and was like taking a deep breath.
Once telemetry came back and we actually saw the spacecraft was there, you could sort of then put together a plan.
I think it was both a relief and a little bit of a weight on our shoulders, because we knew definitively that we had to recover from a situation we had never encountered in flight, and we didn't have extra time to discuss it and overthink it. We had to respond quickly. So we were ecstatic to see our spacecraft again, and then we had to really buckle down and get to work.
There were more serious things about to come to us, so things that required more worry and more concentration.
There wasn't really anybody jumping up and clapping in that moment.
So the first thing we did is to bring down data that told us that that main computer was perfectly healthy. It was just that we had asked it to do too many things at one time.
New Horizons had gone into safe mode. Something's happened to the spacecraft. It doesn't know what to do. There's no protocol for it, so it just goes, it turns as much off that it can, and it calls home, and it basically says, help, I'm in this situation, what do I do?
The spacecraft was spinning, which was a very safe state for the spacecraft, but it's a state where it cannot take any pictures.
Autonomy was no longer loaded on CNDH-1, so the spacecraft switched over to the basically the remote terminal, CNDH-2. And we were safe. We were able to communicate with the spacecraft, but we were in sort of unknown water at that point.
And initially they kind of told me, we don't need you yet. Stay home and rest. So by about 8 o'clock that evening, my kids, my husband went to watch the fireworks, and I sat on the couch to rest and thought, wait a second, I'm not resting. So I came in anyhow.
I called my wife when I realized what had happened, and I told her, I said, it's going to take everything we have to pull us out of this. I mean, this is rock bottom.
And so we just all picked up the pieces and we got out our checklists and we did what we were trained to do.